Hello students and welcome to the nomenclature lecture. We will start with ionic compounds. We did mention that when we write an ionic compound, we start with the cation followed by the anion. The cation normally takes just the element name. So what does that mean? That sodium, whether it's a neutral atom or a cation, I still name it sodium. All metals except group 1A, 2A, aluminum plus 3, cadmium plus 2, silver and zinc, you have to indicate their charge with the Roman numerals. What does that mean? It means, I'll give you an example. Magnesium, I'm just going to call it magnesium. Why? It's a group 2A. Silver plus 1 is also just silver because it is one of those exceptions in red. However, when I have iron and I want to call it, I have to say iron and between parentheses 2. So I am indicating the charge. Anions, we add the ending IDE, ite, to the first part of the element name. Or if it's a polyatomic anion, so if the anion is a polyatomic anion, you just put the name of the polyatomic anion. So here are examples. Carbon, negative charge carbon, -4, is carbide. Nitrogen, for example here, is nitride. Oxygen, oxide. Sulfur, sulfite. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide, and so on. Need to memorize ones here in, now it's not a lab packet anymore, it is on Canvas shell. I do have a document for you with the elements and the polyatomic ions you need to memorize. Please make sure you go to module week 2 and you will find that document before, after the assignments and before your actual assignments start. Here are some common anions. The one with negative charge or -1, hydride, fluoride, iodide, and I want you to pay attention. It can be monoatomic ion with one atom, and it also can be polyatomic anion like cyanide ion, hydroxide anion. We have oxide, peroxide. So this is here, guys, an oxide. A peroxide is 2 oxygen atoms together having a -2. Nitride ion, and there are some polyatomic ions that have -1 charge, like the acetate. Here is the chlorate, the perchlorate, nitrate, permanganate. And then you have the polyatomic ions with 2 plus -2 charge, like carbonate, chromate, dichromate, sulfate, and then polyatomic ion with -3 like phosphate. Now, when the cation, like iron for example, has 2 different charges, there are 2 ways to name it. The first is to just mention the charge, iron 2 for Fe plus 2, iron 3 for Fe plus 3. But also there is the older way in which we give -ic ending for the higher charge and OUS ending for the lower charge for that specific metal. So iron 2 is ferrous because 2 is less than 3, and iron 3 is ferric. You know, like you can see here, you have chromous and chromic for chromium 2 and chromium 3. Now, mentioning mercury here, mercury 1 and mercury 2, is an important thing to pay attention to. Mercury 2 does not have anything special, just regular, a monoatomic cation with a +2 charge. So that here will be mercury 2. Mercury 1 should be 1 mercury with a +1 charge. Actually, it is. However, naturally in nature, it doesn't exist in a monoatomic form. It exists as diatomic, so 2 of them together, always. This is how they exist. And because this is such an inappropriate and not practical way to write, the way we express Mercury 1, it's 2 mercury atoms together have a +2 because each one of them has a +1. So that here is what we call Mercury 1. Okay, now let's name this compound. How would I know the name of the compound? Here is how you think about it. It is an ionic compound, metal and non-metal, and it did combine with 2 chloride anion. Now, iron can change charge on me, so I have no clue what is the charge of iron. But the chlorine is a nonmetal in a group 7. It will always be -1. So I needed 2 chlorine to balance 1 iron. So this iron should have had +2. So now when I call the name for this one, it will be iron 2 chloride or ferrous chloride. For this one here, iron needed 3 chloride anion, which means that iron had a +3 charge, and the name will be iron 3 chloride or ferric chloride. Let's see if we understand the naming of ionic compounds. Name the following compounds. So this here is barium. Barium in a group 2A, so I don't have to mention any charge. So the way I'm going to call it is barium chloride. Potassium is in group 1A, and oxygen will always have a reliable -2. So I'm just going to mention it as it is, potassium oxide. Tin is one of the transition metal that can have more than 1 charge. So if I want to name it, I do have to figure out first what is the charge of tin. Very common mistake, please pay attention. Very common mistake students do. They see the 2 here and they think it's tin 2. That's not how you figure out the charge. The way you figure out the charge is by saying, okay, I needed 2 sulfur. Sulfur is a reliable atom, meaning I can always predict its charge. It is a nonmetal in a group 6A. Every sulfur will have -2. These 2 sulfurs were balanced by 1 tin. So that tin should have a +4. So now the name will be what? The name of this ionic compound will be tin 4 sulfide or stannic sulfide. Next compound, I have a magnesium, which is group 2A. I don't have to mention any charge. And I have hydroxide as my anion. So magnesium will be mentioned as magnesium, no changes. And hydroxide is a polyatomic ion, so I will just mention its name. Magnesium hydroxide. This is here is cobalt. Cobalt is one of those transition metal that changes charges. Therefore, I need to figure out how to predict the charge. This is here is a polyatomic ion, and it's called hypochlorite. Hypochlorite has -1. I needed 2 of them for this cobalt, which means this cobalt should have had a +2 charge. So now when I name this, it will be cobalt 2 hypochlorite or cobaltous hypochlorite. Next is potassium with nitrate. Potassium is a group 1A. I don't have to change anything, so that will be potassium nitrate. Last one, let's do this one together. What do I have here? I have 2 chlorine. Each one is a -1, and I have Hg2. In order to balance that -2, this has to have a +2. But I had both 2 of them, or it's a diatomic ion. Therefore, when I mention the name, I mention the name for mentioning the charge that does present on every metal atom. So in this case, it will be mercury 1 chloride. Now, some of you might tell me, well, how does mercury 2 chloride look like? Well, this is mercury 2. If it's a mercury 2 chloride, then mercury +2 will need 2 chloride to balance it. So the formula will be one mercury with 2 chlorine. That will be mercury 2 chloride. Now let's determine the formula from the name. Lithium oxide. Now if I am looking at lithium oxide, then lithium group 1A and oxide. Okay, what should be the formula? Lithium group 1A will always have a +1, and oxide is oxygen with a -2. This is not balanced, so I need to balance it with another lithium. Therefore, the formula of this compound should be Li2O. Let's look at the next one. Nickel 2 phosphate. Well, here is nickel. 2 means a +2. Phosphate is PO4 -3. Now look at this. This is not balanced. I have more negative charges than positive charges, so I fix that with adding another nickel. Now I have more positive charges than negative charges, so I fix that by adding more phosphate. Now I have -6 and +4. I fix that by adding a positive charge. Now I have +6, -6. Now I am done. What would be the formula of that? Ni3. I used 3 of them, and I used 2 phosphates. Okay, now naming oxyanions, which are polyatomic anions with oxygen. If 2 oxyanions are in series, the fewest oxygen will have the anion ends in "ite", like this here will be nitrite, and the most oxygen will ends with 8, so this here will be nitrate. If I have 4 oxyanions in series, like this one here, I'm going to teach you my little trick to name it. So the 2 in the middle here is ClO3 -1 and ClO2 -1. The fewest one will be ite ending, so that will be chlorite. And the highest one will be chlorate. When you look to the next one here, this is even 1 oxygen higher. So what I say, I will call it pair, which is in science means more, perchlorate. So I have more oxygen in this one. And here I have even 1 less oxygen than chlorite, and in science to indicate less we use the word hypo. So this will here be hypochlorite. There are some patterns for polyatomic ions that you can use to make your life easy. Elements in the same column for ions like has same oxygen number almost and charge. So let's look at that. So for example, carbonate and silicate, 3 oxygen, -2. You can have phosphate and arsenate here to make some like comparison. Chlorate, bromate, iodate. So this is just, it can help you to to understand where the pattern is and hopefully make memorization a little bit easier. If the ion starts with hydrogen, then we add the word hydrogen or bi prefix before the name and add 1 to the charge. What does that mean? Let me give you an example. This is carbonate. If I add a hydrogen, and when I add a hydrogen, hydrogen is normally added as a hydrogen +1. HCO3, now the new charge will be -1 rather than -2 because hydrogen did neutralize one of these negative charges, and the name of this polyatomic ion will be hydrogen carbonate or bicarbonate. Okay. Molecular compounds are compounds that have or made of nonmetals, and some of them have common names, like H2O is just water. We don't call it dihydrogen oxide or whatever. We just call it water. NH3 is ammonia. CH4 is methane. So some of them do happen to have common names, but most of them we need to follow the following rules to name them. The first thing you do, you take the first element, which is normally the more metallic element, and you get the name of that, and then after that you put the name of the second element with the IDE ending. Let's look at that. We also have to use prefixes to indicate number of atoms, because right now we don't have charges to allow us to predict that. So we have to mention the number of atoms using prefixes. Here's the prefixes for you. For 1 we use mono, for 2 we use di, for 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. You definitely need to memorize those. Now, if the first element happened to have one atom, we do not mention mono. We drop the A or the O of a prefix when we combine with oxide or iodide, so we don't have two vowels next to each other. And this is pretty much the rule. Prefix, name of the first element, prefix, the base name of the second element, plus IDE ending. Now remember, if the first element happened to have just one atom, we do not have a prefix, which means we do not mention mono. We do not use prefixes for compounds that are made of hydrogen and one halogen. So, for example, we don't say hydrogen monochloride, we just say hydrogen chloride. If it was a fluoride, it's hydrogen fluoride or hydrogen iodide. Hydrogen and group 6A will combine together, and we also do not have a prefix. So in this specific example, we're not going to say dihydrogen sulfide. We're just going to say hydrogen sulfide. That's one of the exceptions. Now let's look at the molecular compound. Now if I want to name these here, the first one is nitrogen, the element as it is. I have 3 fluorines, so I'm going to say nitrogen trifluoride. Next one, sulfur and 2 oxygens. The first element we do not mention mono, so what are we going to say? Sulfur dioxide. Next one, I have 2 nitrogens and 4 chlorine, so I'm going to say dinitrogen tetrachloride. Next one, I have 1 nitrogen and 2 oxygen, so I'm going to say nitrogen dioxide, which is a toxic gas. Next one, I have 2 nitrogens and an oxygen, so I'm going to say dinitrogen monoxide, which is what we call the laughing gas. Hydrogen iodide is, as I said, one of the exceptions. When you have a hydrogen with a halogen, you just say, you don't have any prefixes, hydrogen iodide. Now, sulfur tetrafluoride, it means you have 1 sulfur with 4 fluorines. So what will be the formula? SF4. All right, good. Now, naming acids, we have almost 2 types of acids, and therefore 2 ways to name acids. So the way you name acids, you have first to identify what kind of an acid are you looking at. So let's start with this. Definition of acids, they are compounds that give a hydrogen cation once in water. We have the first type of acid that we call binary acid. In a binary acid, the acid is made of hydrogen and 1 type of nonmetal. So that will be hydrogen with a chlorine, for example, or hydrogen with sulfur. which is a hydrogen and one type of nonmetal, or one atom of nonmetal. How do we name the acids? First, we have to identify that they are acid by always say aqueous, which means they are in water. And we take the anion. So what is the anion for this acid here? The anion is a chloride, okay? Once it becomes an acid, all you do is you put the beginning hydro, and then the halogen here, or the nonmetal, will have ic ending. So that will make this to be hydrochloric acid. Now, if the acid was this one here, then this will be hydrofluoric acid. If it was this one here, this is sulfur, then that will be hydrosulfuric acid. If it was this one here, then that will be hydrobromic acid, and so on. Now, the second type of acid are what we call oxyacids. These are made of having hydrogen with polyatomic ions. So, now if we look at this, here is a polyatomic anion, chlorate. It's a -1. So when you want to make an acid, you're going to add one hydrogen cation. And what you do, if the ending is 8, then it will become ic acid. If the ending is ite, it will become aus acid. Okay? So now let's try. When we have a chlorate and we start to have the acid here, then that's now is chloric acid. Now notice, I don't have anything at the beginning of the name. It's just the name of the polyatomic ion. I don't say hydro. The polyatomic anion was a chlorate. It will become chloric acid. The polyatomic anion was perchloric. Then the acid will be perchloric acid. The polyatomic anion was ite. Then the acid will be chlorous acid. Hypochlorite, it will become hypochlorous acid. Other examples. So this is carbonate. If you want to make acid out of this, then you're going to have to add 2 hydrogens so you can balance the -2. Right? Sorry for that. Now, what would you call this acid? The way you're going to think of this is like it came from the polyatomic ion carbonate. Carbonate ends with ate, so carbonate will become carbonic acid. So nitrate, when you make an acid out of it, you will add 1 hydrogen, and that will be nitric acid, while nitrite will be nitrous acid. Practice naming oxyacids. So give the formula and the name of the following anions, and then we can make acids out of them. So oxalate is made of C2O4 -2. If you want to make an acid, it will be H2C2O4. Oxalate ends with ate, so the name of the acid will be oxalic acid. Okay? Now, carbonate, I just did that in the previous slide. Sulfite is O3 -2. To make an acid, you're going to have to add 2 hydrogen to balance the -2. H2SO3. Because it's ite, it will be sulfurous acid. Bromide is a halogen. So if you want to make an acid, you're going to add 1 hydrogen to that. So that makes it binary. It's 1 hydrogen and 1 nonmetal. And the way we name binary acid is we say hydrobromic acid. Now here are examples. So I'm gonna mention a couple of them and I will leave the rest of them for your own practice. I will highlight one that I think can be tricky. This one here, a lot of students will name this one the wrong way. They will say lead-2 oxide. The way you again dissect it, you needed 2 oxygens. Each one of them has a -2. So lead should have a +4 to balance that. So that should have been lead-4 oxide. Okay. Another one should be this one here. What charge did manganese have? Well, I used 3 oxides, each one with a -2 charge, and 2 manganese. So what would have been the charge on each manganese to balance that? That should have been +3. So that will be manganese 3 oxide. So hydrosulfuric acid, that means it's a binary, which means it's made of hydrogen and one nonmetal, and that nonmetal should have been sulfur. And since sulfur will need 2 hydrogen, it will be H2S aqueous. All right. Let's see, ammonium carbonate. Ammonium is a polyatomic anion that has a +1 charge. It's a polyatomic, cation that has a +1 charge. Carbonate is a polyatomic anion with -2. You will need 2 ammonium to balance that. So the formula of that will be NH4, 2 of those for every 1 carbonate. All right, so I hope you guys had good practice now and you are more comfortable naming compounds.